The factors that determine fire behavior, fuel, weather, and topography, do so through the requirements for combustion, fuel, heat, and oxygen. Researchers are examining fire at this basic level to help improve its understanding.
So WindNinja is a diagnostic high-resolution wind model that's used to predict near-surface winds in complex terrain, specifically for fire behavior applications. WindNinja is important, especially in complex terrain for fire behavior applications, because the near-surface wind field is highly variable due to the mechanical and thermal effects of the underlying terrain. And even for expert field personnel, it can be difficult to anticipate what the winds might do in complex terrain. One of the really unique things about WindNinja is that it can be initialized with different types of data, which makes it really useful in the field because different types of data might be available in different circumstances and in different regions.
Surface wind modeling is something that we do to simulate how the wind flows over terrain, and that's important to wildland fires because wind has such a big influence on how fast a fire spreads. And so we've developed a model here at the lab, a couple of models, to simulate wind at a very high resolution, to simulate how the wind flows over individual terrain features like a mountain or through a valley. The outputs from our wind modeling can be used by firefighters just to view the wind in Google Earth or something like that. They can also be fed into our fire spread models, so they can actually influence the simulation of the fire as it spreads. So surface wind modeling is important to the public just because it gives us a better idea of what the wind is doing, which then in turn gives us a better idea of what the fire might do. And so better forecasts of where the fire might go and the timing of where it might go has a lot of implications to how we manage fires out in the wildlands.
The research that I do is dedicated toward understanding the physical processes of how fire spreads. We have a couple of different experiments where we look at the different types of heating, whether it's radiation versus convection, how that changes the process of ignition. Other things such as how a fuel being live or dead will change how it ignites and why it will ignite in some circumstances and not in others. We build a lot of fuel beds that are very structured and ordered fuel beds and look at different parameters such as the fuel thickness, how they're arranged, how densely packed they are or loosely packed they are, their location relative to the ground, what happens when you add wind, all of those factors to understand just how long a particular fuel bed will burn for. The new things we're looking at just in the last few weeks is what happens if you put a chimney over a fuel bed. Then that restricts the airflow into the fire plume, which sort of simulates it being one of those very large fires. You get a very big fire plume and you don't get a lot of air penetration into the plume. And we're wondering if and how that affects what the actual burning process of the fuels themselves as they burn.
When a firefighter's on a fire, they're supposed to identify a safety zone that they can go to in the event that conditions change. Across all levels of experience, it's difficult for firefighters to estimate the fire conditions based on changes in the environment. So some of the work that we're doing now is attempting to provide safety zone guidelines based on the vegetation, the slope, and the wind, rather than what the expected fire behavior is going to be. The proposed guideline is going to be 8 times the vegetation height times slope wind factor. So for vegetation that's 30 or 40 feet tall and high winds and steep slopes, you can have safety zones that are very, very large.
My research is dedicated to dry lightning, and most of the research is providing products that use lightning location data to show where dry lightning has occurred the day after the storms have passed. My products are on the WFIS webpage, wfis.net.
For more information, please visit the Fire Fuel and Smoke Science program at www.firelab.org.